Thanks again for joining this workshop. We will start with the session 3, which is one of the 2 sessions of this afternoon. The session is mostly rotates again according to data. So all the speakers are focusing more on the data sharing, data usage, data sharing with users and so on. So I will propose to start with Carl Newell from Internet 2, which has a long time activity on the interaction with the users and data sharing. I stop sharing. Carl, the slides are yours.
All right, thank you. Let me get this going. There we go. All right. Oh.
Thanks, we see them.
All right, great. Well, good morning, actually, good afternoon for most of you. So I'm Carl Newell. I'm a network software architect now at Internet 2. And I'm going to talk to you about a project we've had going on within our community for sharing telemetry and getting access to telemetry, and some of the reasons why we're doing it and our progress so far. So first, I just want to point out some of the people involved in this. This actually officially got kicked off just over a year ago in July. We had an architects workshop when we were talking about our new network, the network that at that time we were designing and proposing, and now we're in the midst of actually rolling out. We put together one of the themes from that was around telemetry, and a lot of interest in how can people get access to more telemetry around the network, and not just their networks but all parts of the network. So we put together a working group spearheaded by Eric Boyd and Joe Breen out of Utah, and a lot of this effort actually has been Joe Breen really getting us together, reaching out to people in the community, and getting to share their data, and then all the other folks listed here, and especially our community, and even moving internationally as of recently. So what do we start doing? Again, got the working group together. The initial phase was just, are people willing to share data, and what data are they willing to share? And really our focus was, at least to keep the scope a little bit smaller, was, science DMZ to science DMZ, or, possibly up to the cloud. The idea is we don't necessarily want to deal with all the data going to a campus at this point, but we want to be able to troubleshoot end-to-end issues. Science DMZ was a good starting point for us. So we're looking at the typical stats from switches and routers, interfaces, IPs, packets per second, bytes, especially errors and discards, anything like that. And also having some success getting similar kinds of data out of data transfer nodes that are in Science DMZs. Moving into phase 2, which is what where we currently are, is now we've touched base with a lot of people. Now we're starting to work more with them to gather the data, start to figure out what we can do with that data, visualization. There's still a lot more to be done. I'll kind of give you an idea of what our progress is. Why are we doing this? I think people already today have touched on a lot of reasons to do this. Again, once we have end-to-end information about our networks, there's a lot we can do for visualization, troubleshooting. But a big focus of this, again, is getting this data across multiple administrative domains. So instead of having silos of telemetry, having access to all the telemetry for analysis. And another one for us that's big to us, and I think it is for your community as well, is just transparency. This is what sets us apart from commercial ISPs, is being able to have access to this data and share this data with our community. So this is a model we sort of put together. So stepping back a little bit, when we started going down this path, one thing we thought about was, can we just get access to people's existing data stores? We thought that idea was probably not a scalable one, especially when you're talking about campuses and the hundreds of campuses we have, and that organizations like in Europe would have. We just wouldn't be able to develop something that got us access to people's telemetry. So what we decided to do was to see if we could actually get telemetry into a shared data store. And we reached out to our community, and most people agreed that they'd be willing to do this, and they like the idea as well. So in the middle is where what we have. Actually, we don't have the message bus at the bottom. The idea is proposed there if there comes a time when we need something like that. But right now, what we have is the Internet 2 TSDS. That's the time series data store developed by the Indiana University Global NOC that runs our NOC services and does software development for Internet 2 and other networks around the US. And that's where all of the Internet 2 data goes. And the Global NOC also currently has, I think, about 20 other state regional networks in the US that they help provide NOC services for. So they already have all the data for that. So we've been working with our community, either various, again, state regional networks or all the way down to campuses to get more data into a centralized data store. To the right of that, on top of that, it's similar to Influx. So we have tools that we can build on top of that. So they have a Grafana data store plugin. So we're now using, a lot of people using Grafana to query the database. On the left side was figuring out what kind of models do we need to get data into TSDS. The top one, that's a pretty standard model from the Global NOC's perspective. That's how they currently query the Internet 2 network and some of the other networks they provide services for. So they're running a central SNMP collector and collecting against switches and routers. The challenges there for bringing new people on board, one is getting them to give shared access for SNMP querying. Them trying to figure out how to restrict that. Getting through ACLs and firewalls all the way down to the devices. We've done this for a few of the participants, and there's definitely challenges there, but we're working through those. The second model is, I thought this would help alleviate a lot of the issues from the first one, and I think it did. It just presented a whole nother set of challenges, but is to build a local collector that a campus could deploy and then push their data up to TSDS. And we did this with a Docker container and a running Telegraph with a custom output plugin for TSDS that was written by Dan Doyle and his group at the Global NOC, and Dan's presenting, I think, about 2 sessions from now on some other stuff. So hoping that, allowing a campus to deploy something locally. So again, with Telegraph for input, in this case, we have the SNMP input plugin, translating that to TSDS output. This works fairly well. The challenges there are there's not a lot of familiarity with Docker yet, especially around networking groups. And so just the challenges of getting a container up and running and functioning properly presented its own set of challenges. But I can say we do have that model working. We probably need a model like that to be working pretty well to scale us out to hundreds of campuses around the country, and possibly thinking about how this effort might work elsewhere, globally. But so we're working on that. And the third model, I don't think we have anything in the pilot yet, though we do have one organization looking to do this. Again, is starting to leverage streaming telemetry on the switches and routers that's available. And again, it's the same, in this case, it's the same Docker container because it's still Telegraph ingesting streaming telemetry data. And it's also something that Internet 2 is definitely interested in with our network is, migrating to streaming telemetry. What we have now here is, getting the data into a central data store, and that allows us to start querying data, across the networks. And just to show some examples of what we can do with it, actually, this example sort of existed before this effort, again, because the Global NOC had data from a handful of networks across the country. But they built what they called the augmented traceroute tool. It's a plugin for Grafana, but basically you can go in and copy and paste the output of a traceroute, is what showing here in the upper right, and it'll go through, and for all the interfaces and IPs that it has data for, it can show you a page full of stats for that, and that's what you sort of see starting here and on this next one. So hop by hop, it can show you the interface stats, and even more importantly, the errors that are happening on the interface. And so what we see this as an opportunity. If you're having an issue on the network, take something that you normally use for network troubleshooting, paste it into this, and you could potentially from that identify where in the path there's problems, and immediately dive into troubleshooting the issue there. Another tool that Joe Breen and his group of students is working on at Utah. This was not directly related to the telemetry yet, but it gives an idea of some of the things we're thinking about. So this is a parallel trace route visualizer, and as you can see, as you run the same trace route between endpoints, you'll start to see the parallelization within the network and how complex a network path may be. So you can think about this again, same thing as we can then translate these hops into lookup against our central data store and start to extract data about these hops, and maybe you can potentially figure out where there's an issue or where there's a bottleneck in the network. So what's next for us? Find more organizations that are willing to share their data. Again, we actually have a list of a lot of US organizations, especially the regional networks and then some of the larger campuses. They're all willing to share. We're just trying to figure out how to make it easier for them to share. I think that's the biggest impediment to progress right now, is it basically takes weeks for us to coordinate, and especially with SNMP collection, to get access to their telemetry. So we're trying to make that easier. And then the second one really is we don't necessarily, we don't want data from everybody, especially other large organizations, and that's probably not feasible. So thinking about groups like GÉANT or ESNet is how do we collaborate and be able to query against existing data stores. And I think that's an effort, probably interesting to this group. I know we've been having conversations with ESNet about doing this. We have access to their network data API. So trying to now start building tools that can query across multiple data stores for the kind of analysis we're interested in doing. And really what we want to start doing is start using the data more. And this was mentioned earlier this morning. It's great to have all this data. Now we have to figure out what it really means and what we can do with it. And so we're just starting to get that effort. I've shown a few of the pieces of what we can do, but starting to find more research organizations or other folks willing and interested in using this data to see what else they can do with it. As an example, Dan Doyle came up with is, path bandwidth calculations and timing optimizations. So you can, knowing an end-to-end path, looking at all the data, interface data for that, you could start to figure out, one, you can figure out where's your bottleneck, and then for that bottleneck, what does it look like a certain time of day if you're trying to do a data transfer, and then maybe even thinking about it a different way. Well, if you know that in the afternoon that link is 9% full, but possibly at 1 a.m. It's only 10% full, you can potentially schedule a data transfer for when a bottleneck has more bandwidth available. And again, just building out our visualization tools and doing more work, and anything else that we haven't thought about. So as I mentioned, we reaching out to a lot of organizations. We've actually been having conversations with Tim and his folks over at GISC and GÉANT about how do we collaborate on that. So we're just kind of still expanding it and getting to the next stage of how do we make it easier to collect this data and make sure everybody has access to the data. I think that's it. Again, if you want any more information, or if you want to participate, feel free to reach out to Joe Breen or myself, and let's start a conversation. Thanks for your time.
Thanks a lot, and thanks a lot for keeping the time with precise timing. Very useful. I think one of the issues we have in Europe is actually to share the information due to legal constraints. So, but I fully agree it would be very good. I propose to continue because to keep the time and keep the questions at the end of the session as the previous time. The next presenters would be Christoph Martin from PSNC on anomaly detection in data center infrastructures. And anomaly detection is one of the main issues related to denial of service and security, which is tightly coupled to data. Christoph, can you share your screen? I think that, okay. Is Christoph seeing the screen now, not in full screen mode? Not yet. And we can't hear you. Maybe you're muted.
Christoph, we can't hear you.
You are unmuted apparently, but we can't hear you.
Can you check the little menu near the mute button, whether you're using the right input device?
We still can't hear you. Christoph, maybe if you can't solve easily, I would ask if the next speaker, which is Dan Doyle, is available, because then we can just swap the two presentations there. Will you be available now to do the presentations?
Yep. Hi there. Can you hear me?
Yes, very well. So thanks for this really late minute change. But if you can start, then I think that will give Christoph the possibility to adjust the microphone.
Yeah, absolutely. So if I make that full screen, can you see it? And hopefully not my comments?
No, that's perfect. Thank you, Diane. Thank you for your presentation on making sense of your big data and empowering users.
Sure. Thank you all. Thank you all for having me here, and good morning from across the pond to most of you. So I'm Dan Doyle. I work over at the Global NOC at Indiana University, and a lot of the talks earlier today have been great and focused on the collection of time series telemetry, that sort of angle of big data. But what I want to talk about is exploring a couple of other different dimensions, some non-time series data, and basically what we've been doing to try to make sense of it all. So before we get going, hi, I don't know if any of you know who we are, but just as a quick level set here, basically Global NOC started in 1998, originally just working with the Abilene network, and now we've grown to support more than 20 networking projects, and they range all over the place in terms of scale. We're headquartered, as you might imagine, with Indiana University in Indiana, and we do a lot of things, but the talk for this is going to be focusing on software and system solutions, basically focusing on big data. The really only intent that I want to get across on this slide is that we've been collecting and analyzing, hopefully actionable items on data for a long time, and to sort of talk about the evolution of how we present this and how we make sense of it as time goes on. So everybody, I think, has talked about the collection of what you would call time series telemetry. And we collect somewhere in the order of 500,000 telemetry measurements, each of which contain multiple metrics. This is bits per second on interfaces, CPU utilization across all of your line cards and route engines and whatnot, the optical strength of your layer 1 network, active testing such as per sonar data. And historically, these have all lived in a variety of applications as isolated items. If you want to check per sonar, you go to Mad Dash, or maybe directly to Esmond if you're a power user. If you want to check the status of your optical strength, you go to a different application. And it requires you to be fairly familiar with a wide variety of tools, not only where they are, but how to use them and what the nuances and quirks are. And they're all collected via different mechanisms, and everything is sort of not as homogeneous as we'd like it to be. That's just sort of a fact of life. But as we look beyond just regular time series data, when we talk about big data or telemetry, there's an entire other set of things that I think are very interesting and that we've started to pull in more and more. And one of these data sets is alarming data, right? So we ingest a lot of automated alarming data. And if you do the math, we're basically handling one alarm every 12 seconds, which, you know, is a fun but useless phrase because, you know, it's usually very bursty when something fails. Most of the alarms that we do come out of Nagios, but sometimes it's trouble tickets, sometimes it comes out of log-based data, and sometimes it just comes out of applications that self-report problems. But there's, again, like with the telemetry data, these might all exist in a variety of different things, and to be able to get a high-level view is very challenging. And then beyond that, there's simply log data, topology data, flow data. We could go on and on. I won't go through all of these. But you know, if you've got hundreds of millions of lines of syslogs and probably even more flow data, and then the topology that represents the intent of your network. For example, which interfaces power which circuits, which customers and which services do those circuits enable, and so on and so forth. All of these are very useful things, but they lead to an end user experience that looks something like this when I'm trying to solve something, right? I have a myriad. Whoops. Sorry, did something happen? I just got a notice about recording.
Yeah, I
Sorry,
don't know what
that was
happened
me
there.
hitting the wrong button.
It stopped and restarted. So please go on, Dan.
Okay, well, Zoom was so unhappy with this user experience that it had to stop recording temporarily, as it should have, because you know, having to do this, particularly at 2 o'clock in the morning, is not an ideal end user experience, right? I've got a tab open for my telemetry system, I've got a tab open for my topology system, I've got a tab open for my alerting system, and you know, who knows what else. I'm trying to sort of align all of these to figure out what the heck is actually going on with a particular thing. And I think this is fairly common and a very organic experience because these things grow up over time, and particularly when the size of all of these systems is small, it's much more manageable, right? It doesn't really matter as much, but as you scale up, you start to feel some pain. So, you know, what we've been using, I think we've seen in a couple of different talks here, we've been using a framework called Grafana for visualizations. If you're not familiar with it, it's basically an open source visualization framework. And the important part is that it integrates natively with multiple backends and that it's open source so that we can extend that integration with our own drivers as needed. And in particular, what I'm going to focus on in this talk is what's called the simple JSON data source installation, simple JSON data source plugin, because that's going to allow us to reuse everything that we already have and build up on top, right? It's fun to dream about greenfield deployments where we're only going to make perfect decisions that we're definitely not going to regret later. But for us, we have a huge amount of data and a lot of legacy items that we realistically can't just migrate off of in the next month or so. So the ability for Grafana to talk southbound to any number of these is actually hugely important. The existing data stores like Influx and Elastic are great, but we have, as I was mentioning, 4 or 5 different sources of truth here. How do we bring them all together? And it sort of looks something like this. And I'll show a couple of examples sort of going forward here. So on the far left of my extremely elegant diagram, we've got an end user, say it's the CEO of a particular company or network. And what they're going to do is look at an executive level dashboard. And what they really want is for all of that information to just be distilled down into them, all of the chaff cut out, and to just answer a simple question depending on whatever the use case would be. And the way that we've implemented this is actually by writing a series of what we call microservices. We wrote them in Python using Flask, although that's immaterial, it's just a detail. And what these do is they implement whatever custom arbitrarily complex business logic we have talking to any number of these existing backend systems. And then northbound, they just speak back using that simple JSON data source back into Grafana. So if we jump back, slide to this is the current user experience of going to every tool individually and relying on the user to synthesize hopefully a correct answer. sort of what we end up now is this more simplified user experience where we're able to distill things down into just what's relevant for the question at hand. So in this particular view, there's actually a lot on this dashboard, but it wouldn't all fit in the slides. We have the universities here in the state of Indiana. Anderson is one of them, and we're able to incorporate specifically their links and specifically their alarms. And this is all done using that logic where we query the topology database that understands, it's documented that Anderson University exists and they connect into the network at these locations. And these are the places where their circuits go. And then we're able to go to all of the needed backend systems, make the relevant queries and say, okay, what might be going on that's important to them? Now, right now, as you might expect, the network looks like they're in great shape. But what this really allows people to do, depending on who the end user is to not really have to make any decisions or to understand any of the systems. All of that's been pushed down into business logic. And the end result is you just simply get a view that is Anderson University. Here's everything we've deemed interesting for Anderson University. Another example that we built up for our own internal use cases is basically all predicated on the idea of a service internally stops working and Slack lights up with 10 different people or 50 different people saying, hey, is mail still working? And without something like an overall status.slack.com, because we all live our lives through Slack and Zoom now, there's no other way to head off that question. So what we wanted to do is come up for our own internal metrics that we have monitoring for. Is there a way to represent these at a high level that anybody can go to? They can see this view and say, yep, mail servers are having a problem. Now I don't have to go ask the sysadmins what's going on. It's a known issue. And we do this through what's called black box style monitoring, which is to say that, we don't necessarily measure the CPU load on the mail server. That's not really interesting to an end user. What we're trying to do is to replicate the end user's experience. So for mail, we may want to send a test email to a test account, verify that it actually gets received in that inbox, and then we monitor that check here. And if that mail doesn't arrive in some sort of timely fashion, we generate an alarm, it shows up on this dashboard, and we can see that the mail servers are impacted from an end user perspective. And the goal, hopefully, is like I said, is to stop that flood of Slack messages anytime something happens. There's a central place to report it to anybody. And the last example that I wanted to talk about here is a dashboard that was created to serve a C-level set of users for the N-Wave network. This takes data sets from network topology, alerting, and ticketing operations, for items like maintenances and outages. And because the focus is on C-level users, much of the detail is intentionally glossed over here. Monitoring checks may indicate something verbose and technical, such as loss of optical signal at layer 1, and then, a myriad of subsequent link failures because all of the higher levels are failing as well. But here, this might just get smoothed over and there's just simply a red line between two of the pops. They don't necessarily care why it's down, they just want to care that it's down. So what we're able to do here is basically build out a view that is tailored to the audience as well, as opposed to, giving them, here are all of the alerts, good luck figuring out what might actually be going on here. What's also cool about this particular view is that the business logic in this case understands the concept of redundancy. A lot of these services are deployed redundantly. And from a monitoring system, you would see if one side fails because that's what the engineers want to see. And they need to go in and work on, fixing the backup or something like that. But if these are redundantly deployed, from the end user experience or maybe even the C-level experience, they don't really care that the backup or the, has swapped over. They really care is the service up, down, and that's sort of what we're encapsulating here. So I'm starting to run up a little on time here. I've already been moving fairly quick, and I apologize, but I've only got just a little bit left. One of the last bits that we saw when adopting Grafana is that it greatly sped up our agility and improved our visibility. One of the reasons why is that it enabled power users to create their own views with the point-and-click interface. So prior to something like this, every request for I need an aggregate view of our Netflix traffic, or I need to be able to look at this particular report over and over again, turned into a software developer task. We would have to create a new web application to do this. And that created a lot of delay in the process because you're essentially building a new application every single time. Now with the ability to generate these in something like Grafana, we have a very rapid ability to try new views, even leading sometimes to throwaway views, where if you need a view for one particular conference or something like that, you can put it together in 30 minutes and then just delete it when you're done. It doesn't really matter anymore. We're seeing that trend in other things like, VMs that are very transient. I think this is data that's very transient, or at least views of data that are very transient. And if software developers don't have to spend all of their time building out these reports, that frees them up to do more interesting things as well. So everybody wins. Customers get their insights more quickly. Software developers get to work on things that aren't, regenerating the same report over and over again, and everything's happy.
2 minutes left.
Yes, as some challenges as we adapted this path, I kind of distilled these down into 3 main points. Codifying tribal or gray matter knowledge is actually quite tricky. When we're talking about, for example, whether or not a service is up or down, a senior engineer probably knows I need to do X, Y, and Z, but a lot of those things are probably not super well defined even in their head, right? I will log into the host and I will look to see if something's not working. Okay, well, what does that really mean? And that generally leads to realizing that we don't really have the right monitoring necessarily for some of these key metrics, particularly in that black box style of monitoring. We might not have a check right now that tries to send an email into the system and verifies that it actually gets all the way through. We might be monitoring disk space and memory on the mail server, but that's not really telling you the end user experience. And then lastly, limitations of the framework. Grafana is great. I have nothing but good things to say about it, but it's still a framework versus custom from scratch code, which means it's really fast as long as what you want to do works inside of that framework. But once you want to bend it outside, it becomes very, very hard, perhaps even impossible. So it's not a 100% replacement, maybe a 95% replacement. And I think that's it. I have 5 seconds left. Thank you very much.
Thank you very much. Thank you very much for accepting to switch. And thank you very much for this quite interesting presentation. It looks that there are a lot to discuss. I kindly ask the participants to ask in the chat, and so that at the end of this session, I ask if Christoph is back and he can voice. Christoph,
Yes, hello. Can you hear me?
Yes, very well. So the floor is yours.
Nice. Sorry for the technical problems. I changed my computer to another one, and I hope everything will work now.
Yeah, so we don't see the presentation yet.
Yes, give me a second. We have...
Yes, we can see the presentation. Full screen. Thank you.
Okay. So my name is Christoph Martin from PSNC, and I would like to give you a short presentation about what we do in PSNC in the context of infrastructure health monitoring in data center. As a computer infrastructure provider, one of our main goals is to keep it functioning well all time. We can achieve this by detecting and fixing any undesirable action and situation. For this purpose, it is necessary to monitor current health state of all components in the data center. Often, it's not enough to know whether something is work or not, and a more in-depth analysis is needed to tell if everything is correct. So the most basic approach is to select a certain subset of performance metrics like usage, CPU, RAM, disk, and network information. Then these metrics are collected and monitored. And if the values do not deviate too much from the normal values, everything is correct. But this method is very problematic and time-consuming and requires a lot of experience from the system administrator. We support various physical devices and virtual machines that differ in physical parameters, architecture, connected devices, and running applications. These are complex systems whose health depends on many aspects, and each of these aspects can be described with multiple metrics. Someone has to define which metrics of a given device are important, what are the relationship between these metrics, and what are the value range in which they should normally be. The condition of each device change very dynamically, but the impact of various actions and malfunction may take time to have consequences. Also, we have to react very quickly on every problem. So therefore, it is necessary to use appropriate tools to support monitoring and analyzing the health of the infrastructure. In PSNC, we test solutions for automatic acquisition and analysis of performance metrics for the rack servers. Our main goal is to inform a system administrator about an abnormal on unresolvable situation. For this purpose, we have prepared an infrastructure for collecting, analyzing, and displaying the current performance of monitored devices. Every device sends a set of performance metrics describing its current state. This data is collected and aggregated in the database, from where they are transferred to artificial intelligence model, whose task is to process and analyze this data in order to detect anomalies. If any anomaly occurs, an appropriate alert is sent. All detected anomalies are saved and presented to user through the visualization model, in this case, Grafana. Here we see an example of anomaly visualization along with a graph of the amount of free memory on the server. And the red dots are anomaly, and we can see that we can detect a lot of very abnormal situations. So what do we do exactly? Anomaly detection is a very complex process, and there are many techniques that address this problem, including statistics, signal analysis, and machine learning. All these methods try to discover and characterize the normal behavior of the given device. First, we need to define what the anomaly will be, and the key here is the historical data that determines what is normal and what is not. Of course, the operator can define abnormal situation himself. Each device is considered individually, even if they run the same application and services. This allows us build a more accurate representation of slightly differences between these devices. What is an anomaly for one device may be a standard behavior for another. In order to determine if something is anomaly or not, we have tested many methods that we have broken into 4 main types. Predictive models, where we try to predict the future. If our predictions are within the error range, we consider it's normal. Otherwise, we assume that it is anomaly. Second are statistical models, which consist in calculating the statistics of the dynamics of changes in metrics and performing statistical tests to check whether a given state is significantly different from the norm. The next type of methods are methods based on checking the probabilistic state in which the server can find itself and the graph of transition between these states. For example, the state can reflect the life cycle of application running on the server. Here we check whether a current state of the server is probable and consistent with the transition graph. The last type that we have tested are methods based on thresholds and rules that directly define abnormal situations. Unfortunately, the threshold values set once for a device may not work when the nature of the operation performed changes. For example, by changing the service running on the server. And of course, we have to set this threshold for each device separately. The chart shows example of models where time is on the x-axis and y-axis determines the level of applicability. The first two is predictive models, and the first is less sensitive model, and next is statistical state and threshold models. This is also only an example. But when we profiling the performance characteristic of the server, we can also use it for other purposes, such as discovering what services are running on the server. We can take a look at the graph of how much free memory, operating memory was on the server and discover running service on the same servers. Each color is an unknown service or application, while the point indicates that at the time the behavior of the server had characteristics corresponding to this service. I emphasize that we don't know the characteristic of application, and even we don't know what application can be run on the server. This is discovered by machine learning algorithm in the course of profiling server behavior. You can look at two applications. First, Blue, which is launched 2 times, here and in the end. And it was running most of the time alone. There is no other application. And the second is Red, which was triggered several times at the different intervals, and it forms a very characteristic sharp shape at the top graph. For both, the detected application activity matches this top graph exactly. In our data center, we not only have servers, but also a network infrastructure. As a part of our cooperation with the industry, we have created a platform for conducting experiments using machine learning for network data. Thanks to this platform, it is possible to perform tests using a real network as well as artificial generated by Spirent test center. For researchers to create new prototypes, we have provided the Jupyter Notebooks environment, which allows them to easily implement and deploy AI models. For what is more, for tester, there is a chatbot on the Slack that allows you to easily run and test experiments. One of our use cases is detection of DDoS attack based on information about net flow in the network. In this case, data from network and Spirent are saved on HDFS, from where it is downloaded and analyzed for occurrence of DDoS attack. Finally, I would like to say a few words about our plans for the future and possible direction for development. And first thing is to integrate the anomaly detection module into a GÉANT network management and as a service and math. And the second direction is the use of presented infrastructure for analyzing inbound network metadata, which could prove more interesting information about network. And I think it's all from me. Thanks for your attention.
Thanks a lot for your presentation, Christoph. I'm sorry about the switches, but I think that you are very well introducing the next step after you collect the data, gather the data, store the data, then you have to analyze the data up to a very high level. As usual, we will keep any questions for the last part. So thanks also for being in very time. And I would like to introduce then the next speakers, which is Alex Moura from Brazil, that will talk about taking OSS network data available to network researchers. So one of the key issues of our production environment. Alex, if you're available, the floor is yours. We can see the slide. Yes. Good morning.
Hi, good morning. Thank you very much for your invitation to present in this event, and I'm really glad that lots of excellent presentations before me, so I can shortcut in a lot of things I would like to say in my presentation. So we are talking here about a work we've started in RNP regarding sharing network data from our production network with network researchers. We are considering that in our case in Brazil, the backbone, the NREN network itself, it's a research asset for network researchers in the academy here in Brazil. And so we have been collaborating with them for many years, and then we know that there are many issues and restrictions when doing research, when you are working in a lab or using software to simulate or emulate network topologies. And frequently the researchers reach out to RMP to ask for real network data, and in that sense we've been trying our best to help them to offer the data they need to validate their research. And but for many cases, like in the security, we sometimes are unable to give them access to some sort of data. So we've been doing some research about this issue of sharing data for network researchers for the last years, and then in the context of technical committee we have organized here for the last 6 or 7 years. We've been working to fulfill this need and request from the academy, which is represented in our evaluation commission for our organization, and its representative, which is a well-known and renowned researcher here in Brazil. He backed this request from the commission, so RMP have some means to share their measurements with the community. And then since 2018, we have been doing some significant advances towards meeting this goal of offering data. The technical committee, which I am a secretary for, we've conducted a survey with some members of our community to identify which kind of data would be of their interest for them personally and for all the community to perform their research. And also we had advances in other fronts, like OGP initiative to share open data from research, and then we've managed to form a working group that created a solution for open data repository here at RMP, and right now it's a temporary solution. We are running a pilot, and we expect in the next years to have some more definitive solution. But we've been successful in involving other organizations in Brazil, and RMP is leading this initiative of open data for research in our country, and representing Brazil in some international forums like RDA. So, but it comes down to the fact that as we were not very well equipped and prepared internally to handle internal processes and lack of also infrastructure and manpower to work on each request we receive for network data. Turns out that we don't have quick solutions for that. So each request require manual processing, and though we have long deadlines to reply. To solve this, we've made a new advance, which is we proposed internally in this committee, this technical committee for monitoring, proposed this new project for 2020. We opened a call, and we selected a project, and a new working group was formed, which is named Micromon. And the idea is that we have asked for this in this call to have some sort of solution that would, in an automated fashion, ingest data which is already captured or stored by any measurement tools and teams, and in many different internal divisions at our organization. And in automated fashion, we would like to have this flow where the data would be processed, analyzed, stored, and ultimately delivered as a open data set using FAIR principles that would give access for researchers to download that data and work in their new projects. So today, RMP is comprised with many different tools, as many of the previous talks already said, and we collect a lot of data using many different approaches and different teams and in different divisions. But many of that information is already processed and displayed in public visualizations, but not necessarily is easier to offer the data sources to the researchers, so they can download the data sets that created those beautiful views and visualizations and graphics. And so the technical committee ran these surveys between 2018 and 20. We've managed to gather their input for which kind of data they would like to have to conduct new research in the computer networking field. And here we have the lists of the two different moments we've asked for their input, and those items are listed in their most request to least requested. So they have asked for active performance measurements, net flow, IPFix traces with some raw data. They have asked for monitoring data of servers, routers, and services, details of the complete physical topology of the network, including nodes and edges, router configurations, logs, etc. And in 2020, with the advent of the pandemic, we ran another round of survey, and they gave us other information of interest for new research, looking into this scenario where the pandemic impacted the network. So they asked for internal traffic level of utilization of circuits, traffic levels, utilization of exchange points, applications, and traffic performance matrices from the internal network and peerings, VPN traffic. So there are lots of different metrics of interest, and then we now have a good overview what would we need to work on to have open data sets. And then we also know better today which kind of data we would have to have extra work, like anonymization or complying with GDPR law, for instance. So in this project, in the call we made, and then when we selected this micromount working group, we've selected this. We worked on this idea of this workflow. So from the data captured, we would work, store, organize, anonymize, and generate new open data sets that could be offered in public storage systems for download, like Dataverse repository, or even if it's that if there is sensitive data that cannot be publicly open, we would store that on a private storage, and that would be accessible only by internal team of RMP, or given access to researchers through some sort of agreement or NDA agreement. And then the micromount team presented this idea of new architecture where they would use this microservices architecture, where they would give us lots of flexibility and scalability, so we could have a number of independent microservices that would talk to each other using HTTP or REST APIs. And they offered this because they know we would have some freedom to choose many different technologies and stacks. We could use multiple different programming languages or different database approaches. So those services can be easily replaced, and there is easy approaches also to continuous integration, continuous deployments. So the idea here is to have this set of microservices in the solution, in the platform, and that would talk to support services in this blue square. And then they would use these application gateways using Flask interfaces to talk to RMP's internal services that are running a number of very well-known tools like Grafana, Cacti, Nagios, and etc. to monitor bandwidth or security or etc. And then we would also offer access to IT teams, security teams, or even C-level staff to up level an overview of many different information we don't have right now. So this working group is rather recent. We have started last August, and we have this first stage of development, which would bring us to a minimal viable product in the next months. We started with a 12-month project, and we expect that to have an extension for at least another 12 months, so we could have round corners in the first minimal product, MVP, to have a stable and resourceful platform running in production in the next 2 years.
A couple of minutes.
Okay, so closing my talk, this talk was inspired by a proposal for a buzz of a feather for the last GNC, which was cancelled. And we would like to bring to this community some questions about the challenges of sharing production academic networks data with for research. So we would like to know how research and education networks are dealing with this kind of requests. How do you fulfill or answer for network requests? Which kind of network data you consider safe to be open, or at the same time, if it's not possible to open the data in raw data, if you anonymize that, it's still valuable for researchers. How do you deal with that? And which kind of data are collected? Are there any best practices would you be able to share with the community? So we would like to bring this discussion to the table with the community. So we would like to have at least a minimum set of data that would be useful for all the research and education networks around the globe to so we can have at least a minimum set of data sets that would be useful for instance, for multi-domain network troubleshooting or analysis. So that's what I have to talk today. Thank you.
Thank you very much also for staying in time. I think this is, I would say, a sore point of sharing data that we share. I don't know if everyone knows, but also the agreement between the European Commission and Europe in general and the United States actually broke a few months ago. So we don't have an easy way to share data between enterprises in the two sides of the oceans. But then I will leave the floor for some questions, if there are some questions. Please, if you are in the auditors, open your mic and ask a question.
There is one question in the chat, Mario.
Okay, the chat from Olaf Kvitten is, to those sharing global data, sorry, oh, geez, it went too fast, sorry. Was Persona considered? I mean, do we have any experience of sharing data through global tools that we are using, like Persona? I don't know, Alpha, Alex, or others, if you have any information on that.
Maybe,
yes, we have some. Sorry, go ahead,
no,
please.
Go ahead, Alex. Sorry.
No, I was just commenting that we had experience with sharing some Persona measurements with internal working groups, and we also consider that many information we collect is already publicly available in our website through Network Weather Map tool or the major circuits of our backbone statistics are all open in our website. So the next step, which would be sharing the numbers that generated those graphics, we believe that we can share that also easily with the community. So we just have to work on the processing the files to share.
So I was also thinking a lot about Persona in your presentation, but also others that were about sharing data between domains. And maybe Olaf was having similar thoughts, because the grand vision for Persona, like before it started 20 years ago, it was to share data. Now these days people see it more as a tool set to do active measurements. But I think the original idea was very much to provide a service, and of course at that time REST and these things didn't exist, so maybe it was a bit too premature. But I think one of the driving ideas was to provide sort of a standard language to share information across domains, and somehow we have there still seems to be a need for that.
I think that's a
Agreed.
really good. I'm sorry, go on.
Yeah, I recall that there is this global research and education network mapping initiative right now, led by GÉANT and Canary, where they are trying to build some sort of dynamic world map, but it's in a distributed fashion. So each NREN would share their part of the information to build the global view. So this is a concrete example where we would have to agree on standards for sharing data on a real-time fashion to build that.
Yeah, one of the nice things with Persona, well, to me it's a nice thing, is that, for example, when I was diagnosing some issue last year, I was able to initiate a test between a Persona server in the US and one in Asia using pscheduler and just invoking it on those systems, and they weren't locked down to prevent that. They were just configured openly, so I could get useful measurements. So in that sense, the data is kind of shared, and then I can run a measurement between two other countries. What it doesn't let me do, and coming back to what was presented earlier, it doesn't show me the load on the interfaces, the state of the buffers or queues, or any other detailed data from the devices that might give me a clue as to why the performance was bad. But I can measure the observed performance between two remote endpoints, which is potentially very useful.
Are there any other question? Otherwise, I won't eat too much of the coffee break.
Yeah, may I ask?
Please.
So, hi Alex, I'm Marinos from National Technical University of Athens. I just wanted to ask you, first of all, it was a great initiative, really. As a researcher, I really admire such efforts. And apart from that, I wanted to ask you how tough was to actually move the process towards giving data to researchers. I know that there are many sensitive information in that, and how did you tackle that in your organization? And how did you convince, I don't know, the other people to actually give those data to researchers?
It's a work in progress. There is a lot of resistance, and I think the bigger challenge we have to face right now is not technical. It's a cultural mindset we need to change internally with many people from many different divisions, right? Really, and but I understand there are concerns, and we are working with them in the very sensible way, telling them that we don't want to expose or bring any problem to their operations, and we are trying to make them part of the discussions where we are developing the solution, and they are giving us their input, and they are the owners of the data. So we will only share what they allow us to do. So I think we are getting a better response from the teams right now with this new working group, and then they are feeling more comfortable when we say, let's say that if we don't need to share real-time data, an embargo for sharing data for last month and back would be enough for protecting the operations, and they said yes, it would work for us. So at least a month and before of data would be available for researchers to do their work.
Thank you very much.
I think there is just the time for one question to Christoph from Vasilis Maglaris. machine learning tools for anomaly detection, any insight on time series correlations versus signature-based detection? It's a very technical question, but I don't know, maybe Christoph has time to just provide a quick answer and then can continue offline.
We tested LSTM and signature-based detection, but I don't think so that we see any big correlation because of this task was very different, and there is some correlation in detected anomalies, but some models detect different anomalies than others. So in this sense, yes, but in the nice, I would say, when we look at the level of atypicality at each model, it's there is no very good correlation between these two techniques.
Thank you very much, Christoph. I propose to close this session here. Thanks a lot all the speakers for their very interesting presentation about data.